Okay, just a quick review for fractions. When you're adding and subtracting a fraction, the thing that's most important to have is a big star, a common denominator. Now, only for adding and subtraction, it must be common denominator. And then for multiplying and dividing, you just multiply the numerators and the denominators with each other. Okay? The reason it's multiplied because the division problem will eventually become a multiplication problem. When you divide a fraction, you will flip the second and multiply. So it all goes back to multiplying. And when you multiply, it's just the numerators, the top numbers, and then the denominators, the bottom numbers, with each other, multiply straight across. Here. Sometimes I draw an arrow to show that it goes straight across numerators, multiply them, then the denominators, multiply them. Now, for, let's say, decimals, there is also a distinction, a separation between these two types of problems. For decimals, when you add and subtract decimals, you need to line up the decimal. Say this is your number, and you have a decimal and another number. And then your second number has a decimal and a number after the decimal. So these decimals, they have to be one on top of the other. Every time you add or subtract, it has to be this way, the decimal one on top of the other, and the numbers are lined up. If there's nothing there, let's say there was an empty space, you can put a 0 to fill that space. Now for multiplying and dividing decimals, it's not important to line up the numbers. You can have a number, decimal, and then a number, and then your next number can be, let's say, just a number here, decimal, number. Okay, the decimals are not lined up. That's okay. The main thing to account for is, I'm going to write it and then I'll show you. Decimal place. Decimal place. So, in the original numbers, there are one digit, two digits, three digits after the decimal. Total. It has to be total. 1, 2, 3 total, let's say, decimal places. Your answer should have 3 total decimal places. So let's say you had a number, 3 numbers, right? Remember, there was 1, 2, 3 numbers after the decimal in the original problem. In the answer, there should be 1, 2, 3 numbers after the decimal. So whatever these numbers are, it doesn't matter. As long as you have 1, 2, 3 numbers after the decimal. That's for, again, multiplying and dividing. Adding, subtracting, you line up the decimals. Adding fractions with unlike denominators. First, find a common denominator. The two denominators are 4 and 5. The common one would be, the easiest thing to do is just do 4 times 5, which is 20. Each new denominator should be 20. To get from 4 to 20, I multiply by 5. 4 times 5 is 20. So, I use the same number 5, I multiply 1 times 5, and I get 5. Now for this fraction, 5 times 4 is 20. 5 times 4 is 20. I use the same number with this numerator. 1 times 4 is 4. Now, the two new fractions have common denominator, which is 20. I can add the numerators now. 5 plus 4 is 9. The answer, 9 over 20. This will be a subtraction problem where you will need to borrow. This is how you do borrowing. First of all, the two fractions are 1/2 and 3/4. I need to find a common denominator. So, I could list all the multiples of 2. They would be 2, 4, 6, 8, and then I could list the multiples of 4. 4, 8, 12. But the 2 that they have in common is 4. That would be my common denominator. And since this fraction 3 over 4 is already has a common denominator of 4, I can just leave 3 over 4 alone. Now over here, 1.5. To get from 2 to 4, I do 2 times 2 to get 4. I use that same number, 2. I multiply 1 times 2 to get 2. Then I bring this whole number 1 down. Now the new problem is 1 2/4 minus 3 over 4. I can't do 2 minus 3, so I need to borrow from this 1. The way I borrow is I change 1 to a fraction, and it has to have the same denominator that this fraction over here already has, 4. I need to have a fraction with a denominator of 4 that is equal to 1. What divided by 4 is equal to 1? It's actually the same number, 4. 4 divided by 4 is equal to 1. So 1 becomes 4 over 4. Now, this 4 over 4, I'm going to add it to 2 over 4. So instead of the 1, it's 4 over 4 now. When I add them together, they have the same denominator, 4. I just add the numerators. 4 plus 2 is 6. And then I leave everything else the same. Subtraction sign, 3 over 4. Now I subtract. They have a common denominator, 4. 6 minus 3 is 3. So my answer is 3 over 4. So the key idea with borrowing is when you cannot subtract, when the second number is bigger, 2 minus 3, I can't do that. I need to borrow from the whole number here. 1 will become 4 over 4. And the reason I picked 4 over 4 is because I need to have the same denominator that is already there, 4. I just pick a numerator that when divided by 4, it gives me 1. It has to be equal to 1. 4 over 4 is equal to 1. Multiplying fractions, 3 over 4 times 2 over 9. When you multiply fractions, you multiply the numerators. 3 times 2 is 6. 4 times 9, 36. Now, I can simplify 6 over 36. Both numerator and denominator are divisible by 6. So I'll divide both by 6. 6 divided by 6 is 1. 36 divided by 6. 36 divided by 6 is 6. The answer 1 over 6. Now let's say I was dividing this problem. 3 over 4 divided by 2 over 9. Like multiplication, you do not have to have a common denominator. You just use the same numbers that are already there. The only thing you do is flip the second fraction, flip the second fraction and multiply. There's a saying, dividing fractions is easy as pie. Flip the second, which is 2 over 9. I'm going to flip it. It becomes 9 over 2. And then I multiply. The first fraction, it does not change. 3 over 4. Now when I multiply numerators and numerators, 3 times 9, 27. And then denominators and denominators. 4 times 2, 8. 27 over 8. And then I can change this fraction, 27 over 8, into a mixed number. Let's do 27 divided by 8. 8 can go to 27 about 3 times. 3 times 8, 24. Your remainder is 27 minus 24 is 3. This mixed number will be this whole number, 3, and this fraction, 3 and 3 over 8. Final answer, 3 and 3 over 8. So remember, for dividing, you have to change it to a multiplication problem after flipping the second fraction.